So I want to talk a little bit about seeing the world from a totally unique point of view. And this world I'm going to talk about is the micro world. I found after doing this for many, many years that there's a magical world behind reality, and that can be seen directly through a microscope. And I'm going to show you some of this today. So let's start off looking at something rather not so small, something we can see with our naked eye, and that's a bee. So when you look at this bee, it's about this size here, it's about 1 centimeter. But to really see the details of the bee and really appreciate what it is, you have to look a little bit closer. So that's just the eye of the bee with a microscope. And now all of a sudden you can see that the bee has thousands of individual eyes called ommatidia, and they actually have sensory hairs in their eyes so they know when they're right up close to something because they can't see in stereo. As we go smaller, here is a human hair. A human hair is about the smallest thing that the eye can see. It's about 1/10 of a millimeter. And as we go smaller again, about 10 times smaller than that is a cell. So you could fit 10 human cells across the diameter of a human hair. So when we look at cells, this is how I really got involved in biology and science, is by looking at living cells in a microscope. When I first saw living cells in a microscope, I was absolutely enthralled and amazed at what they looked like. So if you look at the cell like that from the immune system, they're actually moving all over the place. This cell is looking for foreign objects, bacteria, things that it can find, and it's looking around, and when it finds something and recognizes it being foreign, it will actually engulf it and eat it. So if you look right there, it finds that little bacterium, and it engulfs it and eats it. If you take some heart cells from an animal and put it in a dish, they'll just sit there and beat. That's their job. Every cell has a mission in life. And these cells, the mission is to move blood around our body. These next cells are nerve cells. And right now, as we see and understand what we're looking at, our brains and our nerve cells are actually doing this right now. They're not just static. They're moving around, making new connections. And that's what happens when we learn. As you go farther down this scale here, that's a micron or a micrometer, and we go all the way down to here to a nanometer and an angstrom. Now, an angstrom is the size of the diameter of a hydrogen atom. That's how small that is. And microscopes that we have today can actually see individual atoms. So these are some pictures of individual atoms. Each bump here is an individual atom. This is a ring of cobalt atoms. So this whole world, the nano world, this area in here is called the nano world. And the nano world, the whole micro world that we see, there's a nano world that is wrapped up within that, and that is the world of molecules and atoms. But I want to talk about this larger world, the world of the micro world. So if you were a little tiny bug living in a flower, what would that flower look like? If the flower was this big, it wouldn't look or feel like anything that we see when we look at a flower. So if you look at this flower here and you're a little bug, if you're on that surface of that flower, that's what the terrain would look like. The petal of that flower looks like that. So the ant is kind of crawling over these objects. And if you look a little bit closer at this stigma and the stamen here, this is the style of that flower. And you notice that it's got these are like little jelly-like things that are what are called spurs. These are nectar spurs. So this little ant that's crawling here, it's like it's in a little Willy Wonka land. It's like a little Disneyland for them. It's not like what we see. These are little bits of individual grain of pollen there and there. And here is what you see is one little yellow dot of pollen. When you look in the microscope, it's actually made of thousands of little grains of pollen. So this, for example, when you see bees flying around these little plants and they're collecting pollen, those pollen grains that they're collecting, they pack into their legs and they take it back to the hive, and that's what makes the beehive, the wax in the beehive. And they're also collecting nectar, and that's what makes the honey that we eat. Here's a close-up picture, or this is actually a regular picture of a water hyacinth. And if you had really, really good vision with your naked eye, you'd see it about that well. There's the stamen and the pistil. But look what the stamen and the pistil looks like in the microscope. That's the stamen. So that's thousands of little grains of pollen there, and there's the pistil there. And these are the little things called trichomes, and that's what makes the flower give a fragrance. And plants actually communicate with one another through their fragrances. I want to talk about something really ordinary, just ordinary sand. I became interested in sand about 10 years ago when I first saw sand from Maui. And in fact, this is a little bit of sand from Maui. So sand is about 1/10 of a millimeter in size. Each sand grain is about 1/10 of a millimeter in size. But when you look closer at this, look at what's there. It's really quite amazing. You have microshells there. You have things like coral. You have fragments of other shells. You have olivine. You have bits of the volcano. There's a little bit of the volcano there. You have tube worms. An amazing array of incredible things exist in sand. And the reason that is because in a place like this island, a lot of the sand is made of biological material because the reefs provide a place where all these microscopic animals or macroscopic animals grow, and when they die, their shells and their teeth and their bones break up, and they make grains of sand, things like coral and so forth. So here's, for example, a picture of sand from Maui. This is from Lahaina. And when we're walking along a beach, we're actually walking along millions of years of biological and geological history. We don't realize it, but it's actually a record of that entire ecology. So here we see, for example, a sponge spicule, 2 bits of coral here. That's a sea urchin spine. Really some amazing stuff. So when I first looked at this, I thought, gee, this is like a little treasure trove here. I couldn't believe it. And I'd go around dissecting the little bits out and making photographs of them. Here's what most of the sand in our world looks like. These are quartz crystals and feldspar. So most sand in the world on the mainland is made of quartz crystal and feldspar. It's the erosion of granite rock. So mountains are built up, and they erode away by water and rain and ice and so forth, and they become grains of sand. There's some sand that's really much more colorful. These are sand from near the Great Lakes, and you can see that it's filled with minerals like pink garnet and green epidote, all kinds of amazing stuff. And if you look at different sands from different places, every single beach, every single place that you look at sand, it's different. Here's from Big Sur, like they're little jewels. There are places in Africa where they do the mining of jewels, and you go to the sand where the rivers have the sand go down to the ocean, and it's like literally looking at tiny jewels through the microscope. So every grain of sand is unique. Every beach is different. Every single grain is different. There are no 2 grains of sand alike in the world. Every grain of sand is coming somewhere and going somewhere. They're like a snapshot in time. Now, sand is not only on Earth, but sand is ubiquitous throughout the universe. In fact, outer space is filled with sand. And that sand comes together to make our planets and the moon. And you can see those in micrometeorites. This is some micrometeorites that the Army gave me, and they get these out of the drinking wells in the South Pole. And they're quite amazing looking. And these are the tiny constituents that make up the world that we live, the planets and the moon. So NASA wanted me to take some pictures of moon sand, so they sent me sand from all the different landings of the Apollo mission that happened 40 years ago. And I started taking pictures with my 3-dimensional microscopes. This was the first picture I took. It was kind of amazing. I thought it looked kind of a little bit like the moon, which is sort of interesting. Now, the way my microscopes work is normally in a microscope you can see very little at one time. So what you have to do is you have to refocus the microscope, keep taking pictures, and then I have a computer program that puts all those pictures together into one picture so you can see actually what it looks like. And I do that actually in 3D. So there you can see there's a left eye view, there's a right eye view. So sort of left eye view, right eye view. Now something's interesting here. This looks very different than any sand on Earth that I've ever seen. And I've seen a lot of sand on Earth, believe me. Look at this hole in the middle. That hole was caused by a micrometeorite hitting the moon. Now the moon has no atmosphere, so micrometeorites come in continuously. And the whole surface of the moon is covered with powder now because for 4 billion years it's been bombarded by micrometeorites. And when the micrometeorites come in at about 20 to 60,000 miles an hour, they vaporize on contact. And you can see here that that's sort of vaporized, and that material is holding this little clump of little sand grains together. This is a very small grain of sand, this whole thing. And that's called a ring agglutinate. And many of the grains of sand on the moon look like that, and you'd never find that on Earth. Most of the sand on Earth, on the moon, especially, and you know when you look at the moon, there's the dark areas and the light areas. The dark areas are lava flows. They're basaltic lava flows, and that's what this sand looks like. Very similar to the sand that you would see in Haleakala. Other sands, when these micrometeorites come in, they vaporize and they make these fountains, these microscopic fountains that go up into the, I was going to say up into the air, but there is no air, sort of goes up, and these microscopic glass beads are formed instantly, and they harden, and by the time they fall down back to the surface of the moon, they have these beautiful colored glass spherules, and these are actually microscopic. You need a microscope to see these. Now here's a grain of sand that is from the moon, and you can see that the entire crystal structure is still there. This grain of sand is probably about 3.5 or 4 billion years old, and it's never eroded away like the way we have sand on Earth erodes away because of water and tumbling air and so forth. All you can see is a little bit of erosion down here by the sun has these solar storms, and that's erosion by solar radiation. So what I've been trying to tell you today is things even as ordinary as a grain of sand can be truly extraordinary if you look closely and if you look from a different and a new point of view. I think that this was best put by William Blake when he said, "To see a world in a grain of sand, and a heaven in a wild flower, hold infinity in the palm of your hand, and eternity in an hour." Thank you.